let us deal with some more problems, special problems in indefinite integration. The problem for the instance is integral of x e power x dx by square root of 1 plus e power x. Square root of 1 plus e power x. It is a very good problem. And the substitution must be chosen very, very carefully. You think of, okay, shall we do? Let us take 1 plus e power x is equal to t square. Automatically, e power x dx is equal to 2t dt. Again, e power x is equal to t square minus 1. From this, x is equal to log of t square minus 1 to the base e. Come on friend, what is the fate of I? What shape can it take? In the place of x, we can write log of t square minus 1. In the place of e power x dx, we can write 2t dt by, in the place of root of 1 plus e power x, 1 plus e power x is t square, root t square is t, so that t and t can now be cancelled. Okay, therefore, this is log of t square minus 1 dt 2 into. Well, now we may have to use integration by parts. How can it be used? 2 into integral of log of t square minus 1 into 1 dt. Into 1 dt. Okay. By using integration by parts, let us have the triangular pattern. Log of t square minus 1 2t by t square minus 1 t. Isn't it? That is to use the integration by parts. Come on, what is the answer? This is equal to 2 into t into log of t square minus 1 minus integral of this product 2t square by t square minus 1 dt. Okay, this is 2t into log of t square minus 1 minus 2 2s are 4 into t square by t square minus 1. It can be taken as t square minus 1 plus 1 by t square minus 1 dt. Again, this is 2t into log of t square minus 1 minus 4 into t square minus 1 by t square minus 1. 1 plus 1 by t square minus 1 dt. Well done. The next step, the last step, of course, 2t into log of t square minus 1 minus 4t minus 4 into, come on, 1 by t square minus 1. What shape does it acquire? 1 by x square minus a square. You please recollect the formula for the integral of 1 by x square minus a square. Shall I recollect it? Integral of 1 by x square minus a square dx is equal to 1 by 2a into log mod x minus a by x plus a plus c. I think you might have recollected this. We are supposed to use that formula at that instant. Okay, right, it is 4 into, what is a there? 1. 2a means 2. So, 4 by 2 into log mod t minus 1 by t plus 1 plus c. That's all there is the matter. Of course, the last step is, it is our duty to give the answer in terms of x's but not in terms of t. What is t actually? Root of 1 plus e power x. So, means 2 into root of 1 plus e power x. Minus 4t, that is 4 into root of 1 plus e power x minus 2 into log mod t minus 1 root of 1 plus e power x minus 1 by root of 1 plus e power x plus 1 plus c. There is no other goal. Like that way you simplify this. It's a beautiful problem. It looks special. Something special is there in this problem. You may have to recollect it very carefully if you follow the methodology. The next problem is integral of 1 by sine cube x into cos power 5x whole to the power of 1 by 4. Sine cube x into cos power 5x whole to the power of 1 by 4. The speciality, rather the problematic part here is sine function and cos function are provided with radical exponents. That is sine x whole power 3 by 4 and cos x whole to the power of 5 by 4. This is equal to integral of dx by sine x power 3 by 4 into cos power 5 by 4x. That is the problem here. What do you take? Do you like to substitute either sine function or cos function in terms of t's or some other parameter or variable? It is difficult to decide. By going through all the means, only one idea is suitable for this problem. By hook or crook, try to get tangent functions here. Tan x you try to get. Okay, my view is to get or to take tan x is equal to t. Okay, you must be in a position to prepare the grounds for that. In order to take tan x is equal to t, you must be provided secant square x dx in the numerator. Is it present? No, it's not present. Let us do that. Okay, that is why I am dividing both numerator and denominator by cos square x. 1 by cos square x dx by sine power 3 by 4x into cos power 5 by 4x by cos square x. Imagine what is going to happen. 1 by cos square x is nothing but secant square x dx by sine power 3 by 4x into cos power, come on friend, this is 5 by 4, this is minus 2. What is 5 by 4 minus 2? 5 minus 8 by 4, that is minus 3 by 4. Cos power minus 3 by 4x. We should feel happy for that. Why? Because secant square x dx by this is sine power 3 by 4x by cos power 3 by 4x. What does it mean? It is just nothing but tan power 3 by 4x. Well friends, our dream has come true. You can now take tan x as t. Put tan x is equal to t. Then secant square x dx is equal to dt. Okay, then what is I? Secant square x is t power 3 by 4, that is t power minus 3 by 4 dt. What is the integral of x power n? X power n plus 1 by n plus 1. What is the integral of t power minus 3 by 4? T power minus 3 by 4 plus 1 by minus 3 by 4 plus 1. That is t power minus 3 by 4 plus 1 by minus 3 by 4 plus 1 plus c. Well, what is minus 3 by 4 plus 1? 1 minus 3 by 4. 1 by 4, isn't it? So, it is 1 by 4. This is also 1 by 4. If this 1 by 4 comes to the numerator, it becomes 4. 4 into, this is 1 by 4. 4th root of t. What is t? What is t? What is t? What is t? Tan x. 4 into 4th root of tan x plus c. So, this idea of dividing both numerator and denominator with cos square x has saved the problem. Without any tension or without any puzzle or doubt, we are able to get the answer. Of course, by taking tan x is equal to t. As and when both sine function and cos function are involved with radical exponents, in most of the problems, we prefer to bring tan x into the fray. Like this. Again and again I am saying, my dear, it's not a rule, but it is one of the strategies. It is one of the strategies. We have played that strategy and succeeded in getting the answer. So the answer is 4 into 4th root of tan x plus c. Integral of tan x into tan 2x into tan 3x. Tan x into tan 2x into tan 3x. It is a product. We know the formulae for tan 2x and tan 3x also. If you could expand tan 2x and tan 3x, it will still become bulkier. Then how to tackle with this? Well, you please recollect the formulae from multiple angles of trigonometric ratios. Yes, you see, we have tan 3x is equal to tan of 2x plus x. Am I correct? Use tan of a plus b. What is tan of 2x plus x? Tan 2x plus tan x by 1 minus tan 2x into tan x. Well, my dear, you just cross multiply. What is going to happen? Tan 3x minus tan x into tan 2x into tan 3x is equal to tan 2x plus tan x plus tan x. Therefore, you send this to that side, bring those to this side. What happens? Tan of 3x minus tan of 2x minus tan x is equal to tan x into tan 2x into tan 3x into tan 3x into tan 3x. That we have. Therefore, tan x into tan 2x into tan 3x. In the place of this lengthier product, what can you have here? This is tan 3x minus tan 2x minus tan x dx. The product has been transformed as a sum, or rather difference. Tan 3x minus tan 2x minus tan x. My dear friend, this is to be recollected. Of course, if you could not get this idea, there is another idea also. What is that idea? Let me see. From compound angles of trigonometric ratios, we have a plus b plus c is equal to 0 or n pi implies tan a plus tan b plus tan c is equal to tan a tan b tan c. I think you could have recollected it. If at all a plus b plus c is either 0 or n pi, a plus b plus is equal to 0, a plus b plus is equal to pi, a plus b plus is equal to n pi, 2 pi, 3 pi, 4 pi, n pi, whatever you have, that becomes an identity. Tan a plus tan b plus tan c is equal to tan a tan b tan c. What is the proof? Absolutely in the similar fashion. A plus b plus c is 0. So a is equal to minus of b plus c. Tan a is equal to tan of minus of tan b plus c. You just cross multiply. You will have the answer. Now, in this identity, take a is equal to 3x, b is equal to minus 2x, c is equal to minus x. Then what do you have? Tan 3x minus tan 2x minus tan x is equal to tan 3x into tan of minus 2x into tan of minus x. Tan of minus 2x into tan of minus x is nothing but tan 2x into tan x. Therefore, this product could be translated, rather transformed like this. Once you get that idea, it's very simple to integrate that. What is integral of tan 3x? For tan x, it is log secant x. For tan 3x, it is log mod secant 3x by 3 minus log mod secant 2x by 2 minus log mod secant x plus c. That is the answer. So basically there are no steps or no more simplifications, only one thing, you must get that idea. How can that tan x into tan 2x into tan 3x could be simplified? You try to get the idea from multiple angles or at least compound angles of trigonometric ratios involving tangent ratios. So that it is log secant 3x by 3 minus log secant 2x by 2 minus log secant x plus c is the answer. That is the question we try to follow. Integral of dx by fourth root of x power 4. Fourth root of x power 4. What do you take as t? What is the suitable substitution? How to guess it? Okay. Let us first of all simplify it to a suitable form so that t can easily be chosen. T can easily be chosen. If at all you want to take something as t, its derivative must be available beside dx, isn't it? We may have to plan to get such things. Okay, look here. This is equal to integral of dx by fourth root of x power 4 into 1 plus 1 by x power 4. Any problem? I've got x power 4 out inside the fourth root. Okay then, this is equal to integral of dx by, what is fourth root of x power 4? X into 1 plus 1 by x power 4 whole to the power of 1 by 4. Come on, think of the step. I would like to take 1 plus 1 by x power 4 as t. Okay, what is its derivative? What is its derivative? Minus 4 by x power 5 is coming. By x power 5 is coming. Okay, how to get it? So this is equal to x power 4 dx by x power 4 dx by x power 5 into 1 plus x power 4 whole to the power of 1 by 4. You can write it. Now, let's call this I. The next one, let 1 plus 1 by x power 4 is equal to t power 4. 1 plus 1 by x power 4 is equal to t power 4. So that minus 4 by x power 5 dx is equal to 4t cube dt. Dx by x power 5 only. So from this, dx by x power 5 can be written as minus t cube dt. 4 can be cancelled. Minus t cube dt. Okay. Think of I. What is I? I is equal to dx by x power 5 minus t cube dt. X power 4. What is x power 4? 1 by x power 4 is t power 4 minus 1. So x power 4 is 1 by t power 4 minus 1. We have given the explanation for the numerator. And in the denominator, what do you have? In the denominator, 1 plus 1 by x power 4 is t power 4. T power 4 whole power 1 by 4 is t. Is t. This is minus of t square by t square minus 1 into t square plus 1 dt. Well done. Again, that can be split as t square plus 1 plus t square minus 1 by t square plus 1 into t square minus 1 dt. I think you could have followed. T square plus t square, 2t square. But there t square is only present, so you take half here. Plus 1 minus 1, go away. It makes no harm at all. Therefore, I could have written t square as like this. Without keeping anything in my mind, I have directly put this step first of all. Why? It is necessary, because it is necessary. Why? You split again into two parts. What is going to happen? Minus 1 by 2 into t square plus 1 by denominator, 1 by t square minus 1. T square minus 1 by denominator, 1 by t square plus 1 dt. It is very clear to say and to see and to write that these two belong to standard formulae. Come on, what is the integral of 1 by t square minus 1? 1 by 2a log mod t minus 1 by t plus 1 plus tan inverse t. The only thing that remains here is you may have to replace t again in terms of x's. Where could you have it? What is t? 4th root of 1 plus 1 by x power 4. You may have to write. That will be the answer. You see, my dear, the way of making an attack on the solution is to be discussed and known. Yes. Like that, we make an attempt and solve such questions. No doubt it is a beautiful problem. You see, in so many problems in which radical exponents are there, such things will generally happen. Yes. You have to get such type of ideas. That's it about the problem. You go through it once again. X power 4 into 1 plus x cube whole square. Here we are not having any radical exponents. No doubt there are natural numbers, x cube and x power 4 are available. If you take x power 4 as t, you must be able to have 4x cube in the denominator, in the numerator. It's not present. Even if you take 1 plus x cube is equal to t, then 3x square must be there. It's not there. You may have to create. You think of which option is more suitable. Do you want to take x power 4 as t? Then you may have to multiply with x cube on both numerator and denominator. Then it becomes x power 7 and this is x cube. No suitable transaction is possible. Whereas if you take 1 plus x cube as t, it is quite possible. Why? Because then you may have to multiply both numerator and denominator with x square. X square, this becomes x power 6, this is x cube. Okay, something can be done. I think you could have followed my idea. If you take x power 4 as t, 4x cube dx must be dt. You have to multiply both numerator and denominator with x cube. In such a case, it becomes x power 7 and it becomes x cube. Between x power 7 and x cube, a suitable and pleasant transaction is not possible. Whereas, if you would like to take 1 plus x cube as t, or t square, whatever you say, 3x square dx is equal to dt. So, numerator and denominator must be multiplied with x square. Yes, of course, with x square. If you multiply it with x square, then x square here, this becomes x power 6. This is x power 6 and this is x cube. Okay, t minus 1 whole square can be written. There is a transaction. That is the way to think of. Well, my dear, we have decided to take 1 plus x cube as t. 1 plus x cube is t implies 3x square dx is equal to dt. Well, you observe what I am doing. Is it right? Okay. Send this 3 to this side. 1 by 3 into integral of 3x square dx by x power 6 into 1 plus x cube whole square. Now the things are favorable. Now the winds are favorable for our idea. What is that idea? For our idea, that which we have decided in the beginning itself, is we are supposed to take, come on, what do you take? 1 plus x cube is equal to t. Okay, 3x square dx is therefore dt. What happens to I? I is therefore equal to 1 by 3 into what is 3x square dx? dt by x power 6. See, x cube is t minus 1. Then x power 6 is t minus 1 whole square. Into 1 plus x cube is, what is 1 plus x cube? T square. Is t square. Again, this is 1 by t square into t minus 1 whole square dt. Automatically, 4 partial fractions will be had. A by t plus b by t square plus c by t minus 1 plus d by t minus 1 whole square. It is 2 by t plus 1 by t square minus 2 by t minus 1 plus 1 by t minus 1 whole square. That is, you may have to split using partial fractions. There is no other go. You must do that. Thereby correcting the answer as 1 by 3 into 2 by t, 2 log t, 1 by t square minus 1 by t minus 2 log t minus 1 minus 1 by t minus 1 plus. Well, what is t? 1 plus x cube. You may have to replace t by 1 plus x cube. Do it. This is 1 by 3 into 2 log 1 plus x cube minus 1 by 1 plus x cube plus 1 plus x cube is t. T minus 1 is x cube. 2 log x cube, 6 log x. Of course, this is minus. Minus 1 by x cube. That is the answer. My dear friend, idea is important. You're supposed to multiply with both x square in both numerator and denominator. Observe the way of attacking, way of proceeding. X plus 1 into e power x by cos square x e power x dx. My dear friend, I don't say that is difficult. Some speciality is there, of course, no doubt. The reason for that I am tackling with the problem on the board is, it is so famous. It has been asked for so many number of times. Yes. And some special attitude must be there, of course, to solve it. Special idea must be there. What is that idea? Look here. Let x e power x is equal to t. I have told in the beginning itself, it's very, very easy. The importance is about its popularity. It is famous. Okay. Differentiate it with respect to x on both sides. U derivative into v plus v derivative into u dx is equal to dt. Well, you get e power x out. 1 plus x into e power x dx is dt. Well, in what way can it be simplified? This is equal to dt by cos square t, isn't it? 1 plus x e power x dx entirely is nothing but dt by cos square x e power x. What is x e power x? It is nothing but t cos square t. What is 1 by cos square t? What is 1 by cos square t? It is secant square t. So that we can write this as integral secant square t dt. And very simple, very, very happy answer. Integral of secant square t is just nothing but tan t plus c. Hence the answer is tan of x e power x plus c. Of course, special attention need not be applied here, but you have to remember this because it is famous, it is useful. That's important. Of course, the simple idea, which is also a famous idea that every student can get this idea by simply looking at x plus 1 into e power x in the numerator and x e power x in the denominator. Every person can easily get that idea, of course, but it is famous. That is why I have tackled with this problem, I dealt with this problem. Anyway, go through it once again. Integral of dx by x power n into 1 plus x power n whole power 1 by n. Again, radical exponent is being absurd. What is the way to get this? How to get it? Well, in almost of all the cases, in almost of all the problems in which such things occur, we have used a common procedure. What is that? You can recollect while I am doing. You observe me very carefully. This is equal to integral of dx by x to the power of n into x to the power of n into 1 plus 1 by x to the power of n whole to the power of 1 by n. That is, I have got x power n out in this bracket inside. Okay, x power n whole power 1 by n is x. X into x power n is x power n plus 1 into 1 plus 1 by x power n whole to the power of 1 by n. Now it is possible to take 1 plus 1 by x power n as either t or t power n or whatever you like. Why? Because in the derivative of 1 by x power n, 1 by x power n plus 1 occurs. The derivative of 1 by x power n, what is the derivative of 1 by x power n? Minus n by x power n plus 1, isn't it? Yes. Okay, this is your I. Now, let 1 plus 1 by x power n is equal to, come on friend, what do you like to have? Either t or t power n, whatever you like to have. Okay, let us take it as t. Differentiate on both the sides. What is the derivative of 1? 0. Derivative of 1 by x power n? Derivative of 1 by x power n is minus n by x to the power of n plus 1 dx is equal to dt. 1 plus 1 by x power n is t. Of course, derivative of 1 is 0 and the derivative of 1 by x power n is minus n by x power n plus 1 dx is dt. You see, we have only dx by x power n plus 1 here. For that, what can you say? Dx by x to the power of n plus 1 is equal to minus 1 by n dt. Minus 1 by n dt. Now, let us see what happens to the fate of I. I is therefore minus 1 by n into dt by, come on, dx by x power n plus 1 entirely is dt. T power 1 by n. T power 1 by n. If it comes to the numerator, what happens? This is equal to minus 1 by n into t power minus 1 by n. T power minus 1 by n plus 1 by minus 1 by n plus 1. What is 1 minus 1 by n? 1 minus 1 by n is n minus 1 by n. This is equal to minus 1 by n into n by n minus 1. Why? Because it is 1 minus 1 by n is n minus 1 by n. If it comes to the numerator, it becomes n by n minus 1 into t power n minus 1 by n plus c. Ultimately, what is the answer? Minus 1 by n minus 1 into t power. What is t? 1 plus 1 by x power n whole to the power of n minus 1 by n plus c. That's it. So, if at all a function is involved with a radical exponent, you grasp a minimum power of x out, so that simplification becomes easier. That is the way in which we solve the problem. It's no doubt it's very important. It's a very good problem. There is a similar problem which is exactly in this
in the similar fashion, but a mere transformation of functions to the numerator and denominator there it appears. We shall go through that problem also next. You observe this problem. Integral of 1 plus x power n whole to the power of 1 by n by x to the power of n plus 2. In the previous problem, 1 plus x power n whole power 1 by n is in the denominator, but now it is in the numerator. Moreover, x power n plus 2 is there. What shall we do? Let us see. This is equal to, again as before, x to the power of n into 1 plus 1 by x to the power of n whole to the power of 1 by n by x power n plus 2 is there, x power n plus 1 into x. Let me write. What is the benefit you like to get? You can get x power n whole power 1 by n is x. Mercilessly you can cancel. Happy. What is that? 1 plus x, 1 by x power n whole power 1 by n by x power n plus 1. 1 plus 1 by x power n whole to the power of 1 by n into minus n by x to the power of n plus 1 dx. From where could you get this minus n? We need it because future is before our eyes. We are going to assume 1 plus 1 by x power n as t. So, yes, this is necessary. We have introduced and cancel it here. 1 by minus n. Okay, this is your I. Come on, let 1 plus 1 by x to the power of n is equal to t. Is equal to t. Minus n by x to the power of n plus 1 dx is dt. For that purpose only we could have brought this minus n into the frame. Okay, what is the shape of I? I is therefore is equal to minus 1 by n into t power 1 by n dt. That is minus 1 by n into t power 1 by n plus 1 by 1 by n plus 1. What is 1 by n plus 1? N plus 1 by n. So it is minus 1 by n into n by n plus 1 into t power n plus 1 by n. Because this is in the denominator, as it comes to the numerator, it surely becomes n by n plus 1. So that you can cancel n and n. So that minus 1 by n plus 1 into what is t? What is t? Where is t? 1 plus 1 by x to the power of n whole to the power of n plus 1 by n plus c. My dear friends, you please observe the similarities between this problem and the previous problem. The plan is same. The way of thinking is same. Supposition t is same. Dx is same. Answer is different. Yes. It's a beautiful model. Go through it once again. Integral of x to the power of 4 plus 1 by x to the power of 6 plus 1. Beautiful. It's a nice problem. You have to think of not less than for 30 to 45 seconds to get a proper idea. What do you do? Do you divide with x square or x cube or whatever substitution you like to have? A simple idea, a very simple idea simplifies this. What is that? Look here. This is equal to, do not touch the numerator, think of the denominator. It is, let us have one more step, no problem. X square whole cube plus 1 cube. It is in the form a cube plus b cube. What is the formula for a cube plus b cube? This is equal to a plus b into
a power 4, a square plus b square minus ab. Isn't it? By looking at this, we will now get the idea to simplify the numerator. How? It's very simple. X power 4 minus x square plus 1 plus x square. Am I correct? X power 4 minus x square plus 1 plus x square. Okay, this is equal to integral of x power 4 minus x square plus 1 by x square plus 1 into x power 4 plus 1 minus x square plus x square by x square plus 1 into x power 4 plus 1 minus x square dx. Isn't it? Okay. This is equal to, this factor will definitely be cancelled, leaving you 1 by x square plus 1 dx plus integral of x square by x square plus 1 into x power 4 plus 1 minus x square dx. The first part of the integral is very simple. It is of course tan inverse x. Let us now think of the second part of the integral. You please go through it once. I like to remove this so as to simplify that. Go through this once. This is equal to, for this part it is tan inverse x, and for this part it is, come on dear, from where could you get these two factors? From x power 6 plus 1. Okay, you retain the same as that. What is x power 6 plus 1? X cube whole square plus 1 dx is equal to tan inverse x plus I1. Say, I would like to assume that as I1. Okay, bring that I1. What is I1? I1 is equal to integral of x square by x cube whole square plus 1 dx is equal to 1 by 3 into 3x square dx by x cube whole square plus 1. I think you could have got my idea by multiplying with 3. Why? Because I am going to take this x cube as t in the next step, so that it becomes 1 by 3 into dt by t square plus 1, where, come on, what is t? What is t? T is nothing but x cube. T is equal to x cube, dt is equal to 3x square dx. Again, 1 by t square plus 1, it is tan inverse t. So it is 1 by 3 into tan inverse t plus c. That is equal to 1 by 3 into tan inverse of, what is t? X cube plus c. Well, my dear, this is I1. That is the second part of the main answer. You collect this to get it substituted here, so that the final answer is tan inverse x plus 1 by 3 into tan inverse of x cube plus c. It's a beautiful problem. Go through it, the solution once again. Integral of 1 by sine square x plus tan square x. That is the integral before us. 1 by sine square x plus tan square x. How to get it? Sine x is there, cos x is not there. Tan x is here, secant square x is not there. So what do you like to suppose as t? According to our plan, you have to prepare the situation there. Okay. Comparing these two, sin x and tan x is preferable because it has a large scope of simplification. Okay, I like to take tan x as t. Automatically, secant square x dx must be dt. But secant square x is not there. You provide secant square x. How? This is equal to 1 by cos square x dx by 1 by cos square x into sin square x plus 1 by cos square x into tan square x. I think you could have followed. What I have done is, I have divided both numerator and denominator with cos square x. Okay, what is the next step? Secant square x dx by 1 by cos square x into sin square x is tan square x. What is 1 by cos square x? Secant square x. But secant square x is 1 plus tan square x into tan square x. This is your I. Well, our dream has come true. We have planned in the beginning itself to take tan x is equal to t. Now take it. Take it. Put tan x is equal to t. As we could discuss, it's a pre-planned thing. It is secant square x dx is dt. Well done. What is I? Let us simplify. I is therefore equal to secant square x dx is nothing but dt by tan square x is t square plus 1 plus t square into again t square is equal to dt by, let me get t square out, 1 plus t square. Therefore, this is dt by t square into t square plus 2. Let us do a very simple magic, which is a famous one, by t square into t square plus 2 dt. What is the change here? I have created t square plus 2 and t square in the numerator. Actually, there is nothing at all, just nothing but 1. But with this transaction, t square and t square will go away, leaving you 2. That 2 must be cancelled. That is why we put 1 by 2 here. Now it is 1 by 2 into t square plus 2 by denominator, 1 by t square by denominator, 1 by t square plus 2 dt. What is the integral of 1 by t square? Minus 1 by t. 1 by 2 into minus 1 by t minus, come on friend, what shape does it acquire? 1 by x square plus a square, that is 1 by t square plus root 2 whole square. And in the place of a square, what do you have there? 2. For a square, 2. So for a, root 2. But the answer is 1 by a tan inverse x by a, that is t by a, that is 1 by root 2 into tan inverse of t by root 2 plus c. And the only thing remained here is you have to replace t by the expression in terms of x's. What is that? Tan x. In the place of t, we replace tan x. Ultimately, the answer is half into minus 1 by tan x minus 1 by root 2 into tan inverse of tan x by root 2 plus c. Beautiful problem. Excellent. It is a nice problem to look at. Go through it once.